Every frozen pizza begins long before it ever reaches a supermarket freezer. It starts not with toppings or cheese, but with logistics. Massive food manufacturing plants receive raw ingredients around the clock. Truckloads of flour, tomato paste, cheese blocks the size of suitcases, frozen meats, and pallets of vegetables flash frozen at peak freshness. Nothing here is random. Every ingredient is timed, weighed, tracked, and logged because when you're producing tens of thousands of pizzas per hour, even a small delay can ripple across the entire operation. The process begins in the dough room, a cavernous space filled with stainless steel mixers that resemble industrial cement drums. Flour is pneumatically pumped from silos directly into these mixers, combined with water, yeast, oil, sugar, and salt. Sensors constantly measure temperature and humidity because dough is alive. It reacts to even tiny environmental changes. Too warm, and it rises too fast. Too cold, and it won't develop properly. The machines knead the dough with incredible consistency, replicating what human hands would do, but on a scale no bakery ever could. Once mixed, the dough is divided and portioned with laser precision. Each pizza dough ball must weigh exactly the same to ensure uniform baking later. The dough is pressed, rolled, or stretched depending on the style. Thin crusts are flattened into near-perfect discs, while thicker crusts are gently shaped to trap air inside. Some lines even form raised edges automatically, creating that familiar crust ring without a single human touch. From there, the dough moves into a controlled resting chamber. This step is crucial. The yeast needs time to activate, allowing the dough to relax and develop flavor. The environment is carefully controlled so every crust rises evenly. At this stage, hundreds of dough bases move forward in perfect formation, spaced evenly on conveyor belts that never stop moving. Next comes the sauce. Tomato paste arrives highly concentrated and is rehydrated, seasoned, and blended in massive tanks. The flavor profile is fine-tuned by food scientists, balancing sweetness, acidity, and salt, so the sauce still tastes good after freezing and reheating. Automated dispensers deposit the exact amount of sauce onto each pizza base, spiraling outward in hypnotic patterns. Cameras immediately inspect coverage, ensuring no bare spots and no overflow. Any pizza that doesn't meet visual standards is instantly removed from the line. Then comes the cheese, one of the most critical and expensive ingredients in the entire process. Cheese blocks are shredded on-site to preserve freshness, often using blends of mozzarella, provolone, and cheddar depending on the recipe. The shred size is carefully engineered, too fine and it melts unevenly, too thick and it won't spread properly. Automated spreaders rain cheese down in perfectly calibrated amounts, distributing it evenly across the sauce. The sound of thousands of pizzas being blanketed in cheese is constant and unmistakable. This is where automation truly takes center stage. The topping zone is dominated by robotic arms, vision systems, and intelligent dispensers that work together with astonishing precision. Each topping, pepperoni, mushrooms, olives, onions, peppers, sausage, is stored in temperature-controlled hoppers. High-speed cameras scan each pizza as it enters the topping area, mapping its exact position in real time. Robotic topping systems respond instantly. Pepperoni slices are dropped in precise patterns, evenly spaced so every bite feels balanced. Vegetable dispensers adjust for size and density, compensating for irregular shapes so toppings don't clump. Meat toppings are portioned to the gram. Nothing is left to chance. What looks simple from the outside is actually a carefully choreographed dance of machines communicating thousands of times per second. Some factories even use AI-driven systems that learn over time. If customer feedback suggests a topping distribution feels uneven, the system can be recalibrated digitally without changing physical hardware. This allows manufacturers to fine-tune pizzas faster than ever before, responding to market demand in weeks instead of months. Once topped, the pizzas briefly enter a pre-bake or par-bake stage, depending on the product. This step sets the dough structure and locks toppings in place so they don't slide during freezing. Massive tunnel ovens bake pizzas just enough to stabilize them, not fully cook them. Temperatures are carefully controlled to prevent moisture loss, which could lead to dry crusts after reheating. Immediately after baking, pizzas enter one of the most important stages in the entire process: rapid freezing. Unlike home freezers, industrial flash freezers drop temperatures extremely fast, sometimes within minutes. This quick freeze prevents large ice crystals from forming, which would otherwise damage texture. It's the secret reason frozen pizzas can still taste fresh months later. As pizzas emerge frozen solid, they move into the inspection phase. Cameras check shape, topping placement, cheese coverage, and overall appearance. Metal detectors scan for contamination. Weight sensors confirm portion accuracy. Any pizza that fails inspection is rejected automatically. Quality control here is ruthless because consistency is everything in mass production. Packaging is the final step, and it's just as automated as everything before it. Frozen pizzas slide into cardboard sleeves printed with high-resolution images designed to look irresistible under grocery store lighting. The boxes are sealed, coated with batch numbers, and grouped into cases by robotic packers that stack with flawless efficiency. Pallets are wrapped, labeled, and sent directly into frozen storage warehouses where temperatures stay well below zero. From there, logistics take over. These pizzas will travel thousands of miles in refrigerated trucks, moving through distribution centers before finally arriving in supermarket freezers. Weeks or months may pass before someone picks one up, unaware of the immense technological process behind it. What's remarkable is how little human intervention is required once the line is running. Operators monitor screens, engineers analyze data, and maintenance crews ensure machines keep running. But the pizzas themselves are touched by human hands only at the ingredient source. This level of automation isn't just about speed, it's about safety, consistency, and scale. The frozen pizza industry produces billions of units every year, feeding entire countries with a product that's affordable, reliable, and endlessly customizable. What began decades ago as a simple convenience food has evolved into one of the most advanced food manufacturing systems in the world. Beyond the main production line, there is an entire hidden ecosystem that supports frozen pizza manufacturing, and it's just as complex as the machines shaping the pizzas themselves. Ingredient suppliers work months in advance, forecasting demand based on seasonal trends, promotions, and regional preferences. A spike in pepperoni pizza sales in one country can trigger adjustments in pork processing plants hundreds of miles away. Tomato growers plan harvests, knowing exactly how much paste will be required months later. This tight coordination ensures that factories never stop, because downtime in a high-speed food plant can cost thousands of dollars per minute. Energy management is another silent but critical part of the process. These facilities consume enormous amounts of electricity to power mixers, ovens, freezers, conveyors, and robotic systems. To control costs and reduce environmental impact, many plants use heat recovery systems that capture excess heat from ovens and reuse it to warm water or stabilize room temperatures elsewhere in the factory. Some even integrate renewable energy sources or operate during off-peak hours to balance grid demand. Efficiency here isn't optional. It's survival in a competitive market. Food safety protocols operate continuously in the background. Surfaces are sanitized on strict schedules, air is filtered to remove contaminants, and workers pass through hygiene checkpoints before entering sensitive zones. Sensors track not just temperature and humidity, but also airflow, bacterial risk zones, and sanitation cycles. If any parameter drifts outside its safe range, alarms trigger immediately, and sections of the line can be isolated without shutting down the entire operation. This level of control is what allows frozen pizzas to remain safe and stable for long shelf lives. Customization has also become a defining feature of modern frozen pizza production. Flexible manufacturing lines can switch between recipes with minimal downtime. One moment, the line is producing classic cheese pizzas, and minutes later it's assembling gluten-free crusts or plant-based toppings. Modular equipment, quick-change dispensers, and software-driven recipes make this possible. The result is an industry that can cater to niche diets and global tastes without sacrificing speed or efficiency. Research and development plays a larger role than most people realize. teams of food scientists continuously test new dough formulations, cheese blends, and sauces designed to behave better under freezing and reheating. They study how moisture migrates during baking, how fats melt and resolidify, and how flavors change over time in frozen storage. Even box design is tested because airflow inside an oven can affect how evenly a pizza reheats. Every improvement is data-driven, measured, and refined. Consumer behavior also feeds directly back into the system. Sales data, customer reviews, and even social media trends are analyzed to predict what people will want next. If spicy flavors gain popularity, topping ratios and sauce recipes are adjusted. If thinner crusts trend upward, dough processing parameters are modified. This feedback loop allows frozen pizza manufacturers to evolve faster than traditional food producers, staying relevant in a crowded market. Despite all this automation, human expertise remains essential. Engineers fine-tune machines, quality specialists interpret data, and technicians perform preventative maintenance to avoid breakdowns. When something does go wrong, trained teams respond instantly, diagnosing issues that software alone can't solve. The goal isn't to remove humans from the process entirely, but to use human intelligence where it matters most. The scale of this operation becomes even more staggering when you consider global distribution. Frozen pizzas produced in one factory may be sold across multiple countries, each with its own regulations, labeling requirements, and taste preferences. Packaging lines adjust language, nutritional information, and branding without changing the product inside. This adaptability allows a single facility to serve multiple markets efficiently. All of this complexity exists so that in the end, the experience feels simple. You open a freezer, choose a box, and in minutes, you have a hot meal. The convenience hides decades of engineering, logistics, and innovation working together seamlessly. Frozen pizza isn't just food, it's a triumph of industrial design, supply chain coordination, and modern automation. And as technology continues to advance, these factories will only become smarter, faster, and more precise. The next generation of frozen pizzas may be produced with even less waste, lower energy consumption, and greater customization than ever before. What seems like an ordinary product is, in reality, a constantly evolving system that reflects how far food manufacturing has come and how much further it's still going. One of the most fascinating aspects of frozen pizza manufacturing is how deeply data-driven the entire operation has become. Every pizza moving down the line generates information. Sensors record dough elasticity, sauce viscosity, cheese distribution, bake time, internal temperature, and freeze rate. This data is stored, analyzed, and compared against historical benchmarks. Over time, the system learns what perfect looks like and flags even microscopic deviations. A crust that rises a fraction of a millimeter too much, or a cheese layer that melts slightly differently, can be traced back to a specific variable earlier in the process. This level of traceability allows manufacturers to correct issues before consumers ever notice them. Supply chain resilience has also become a major focus in recent years. Frozen pizza factories are designed to operate even when disruptions occur. Ingredients often have multiple approved suppliers, each tested to ensure consistency in taste and performance. If one source of cheese or flour becomes unavailable, the system can switch seamlessly to another without changing the final product. This redundancy is intentional. When a factory produces millions of pizzas per week, stability matters more than anything else. Cold storage itself is an engineering marvel. Finished pizzas are stored in massive automated freezer warehouses where robotic cranes retrieve and place pallets with pinpoint accuracy. These facilities operate in temperatures far below what humans could tolerate for long periods, which is why automation dominates here. Inventory systems know exactly where every pallet is located, how long it has been stored, and when it needs to be shipped. This precision minimizes waste and ensures products rotate properly, maintaining freshness throughout their shelf life. Transportation adds another layer of complexity. Refrigerated trucks, known as reefers, are monitored constantly during transit. Temperature sensors transmit real-time data to logistics centers, alerting operators to any fluctuation that could compromise product quality. Routes are optimized to reduce transit time, fuel consumption, and exposure to temperature changes. Even loading docks are climate-controlled to prevent brief warming during transfers. The cold chain is never broken because a few degrees of variance can undo months of careful processing. Environmental concerns are increasingly shaping how frozen pizzas are made. Manufacturers are under pressure to reduce water usage, packaging waste, and carbon emissions. Many plants now recycle water used in cleaning processes, treat wastewater on site, and redesign packaging to use less cardboard and plastic. Lightweight boxes, thinner films, and recyclable materials are becoming standard. These changes may seem small, but at the scale of billions of pizzas, they make a significant impact. Waste reduction inside the factory is another priority. Ingredients trimmed or rejected during production are often repurposed rather than discarded. Dough scraps can be reprocessed, vegetable trimmings redirected to animal feed, and imperfect pizzas donated or used for internal testing. The goal is to make the operation as circular as possible, where very little is truly wasted. Automation helps here too because precision reduces errors in the first place. The workforce behind these operations has evolved alongside the technology. Today's frozen pizza plant employs fewer manual laborers and more technicians, programmers, and data analysts. Employees are trained to interpret dashboards, troubleshoot robotic systems, and maintain complex machinery. It's a shift from traditional food production to something closer to advanced manufacturing. The pizza factory of today has more in common with an automotive plant than a kitchen. Behind every frozen pizza is a silent army of machines working in perfect synchronization, turning raw ingredients into a product designed to survive freezing, transport, storage, and reheating, all while still delivering comfort in a cardboard box. And the next time you slide a frozen pizza into your oven, you're not just heating food. You're finishing a process that began in one of the most automated factories on Earth.